Hello and welcome to That Fabric Guy. My name is Bas Land and every week on YouTube I will teach you about Microsoft Fabric. And today we're going to look at Fabric data agents. We've done that before, but today we're going to optimize them for analysis. We're going to combine multiple data sources. We're going to provide advanced instructions to our data agents. So let's dive right into my laptop. On the screen here, we see a workspace, and in a workspace, I've created a folder for data agents. Now, forget about the notebook. That was just in preparation. Forget about the validation report, also just for preparation. But we are going to focus on our Gold taxi data semantic model and our taxi analysis data agent. So as you know, I like to use the New York City taxi and limousine companies open source dataset. It's a over 4 billion line dataset containing all the taxi data from New York City taxis from 2009 up until now. And it's a massive data set. It's nice to show in demos. And today we're going to look at how we can combine both an aggregated data set, because 4 billion lines is a lot. So we're going to aggregate by taxi type, by day, by pickup location. And we're going to look at how we can then look at the aggregated data versus the line level data in a data agent, so we can chat with that data set. So in the data agent that I created, I've added two data sources. Gold is my Lakehouse. That is the Gold Lakehouse that contains all the taxi information. And as we can see here, I've selected a few tables that are available for the data agent. It's dim dates, dim locations, drop off and pick up, taxi types, times, and then it's effect taxi data that is partitioned by year, month, and taxi type. All right, so this is high level, this is highly detailed information, 4 billion lines of data and a lot of columns as well. So if we look at here there is a lot of measure columns. We can even look at how much toll was paid by the taxi driver, what was the MTA tax amount, and so on. Now, if we are looking for most questions that a user might ask, we might be referring to the semantic model that I created with an aggregated set of data. So in the fact taxi trips aggregate table in the semantic model, I've created just a few measures with the number of passengers, number of trips, and the trip distance in miles, and also the average passengers per trip and the average trip distance in miles. Across just 3 dimensions, we have the taxi types, yellow, green, Uber and Lyft and so on. And then we have the dim locations for pickup and dim dates, which is the day for pickup. So this is aggregated by day, by location, and by taxi type. And there's only a couple million lines. So it's about 1,000 times smaller and therefore way faster. Most of the questions that I can think of can be answered by this semantic model. But sometimes we need to dive into the Lakehouse. This is a very real scenario, maybe not for taxis, but for other companies, this could be a real scenario. Now, if we are just putting this in and we start writing questions to the model or to the agent, we might get good results. But as of 2026, we all know that AI likes to hallucinate, and we want to prevent that when we are using AI to analyze our data and make decisions for our company. So we need to set up the agent properly. The first thing we're going to do is we're going to go to the setup tab in here, and we're going to click on agent instructions. And here on agent instructions, there is this big piece of text. Basically, it's a markdown box that you can put markdown code in, and that markdown code then will generate some text for us. And with this markdown, we can give detailed instructions to the agent. Now, Microsoft has an example markdown file that is set up like this. So we have objectives, data sources, key terminology, guidelines, and handling common topics. And I've entered information about our model. So I say, I want to help users analyze taxi trips across time and locations. I describe the data sources, and I want the model to use the taxi data agent semantic model for all questions that can be answered using the aggregate level of data, and considering measures that have the trip count, passenger count, and so on. For any other questions that cannot be answered on that granularity, on that aggregation level, or with those measures, maybe the user wants to know about the MTA tax amount, then we need to refer back to the Lakehouse called Gold. In terminology, I've entered the taxi types are the types of taxi, yellow, green, for hire vehicle, high volume for hire vehicle, and so on, that are found in the taxi types dimension, because when I was testing this, the model did not understand my questions about taxi types, and it was not referring to the taxi types dimension for whatever reason. And I tell the model to give context with the numbers. For example, I will just type it in here. Yeah, so I added now to that, for example, don't give just a list of taxi trips volumes, but describe the trends you're seeing, the comparison to last year and such. Be brief but interesting. So what I want the model to do is to give a little bit of context around the list of numbers, because otherwise we could just use a Power BI report and the data agent can do so much more than that. On handling common topics, I've not put in anything for now. Now this is the overall agent instruction. We can also put in data source instructions, and we cannot do that for the semantic model. A semantic model is just a bunch of tables with relationships and DAX measures, so that's pretty easy to do, I'd say. But for a Lakehouse, we can put in data source instructions and sample queries. So let's go over both of those as well. So for data source instructions, we can put in both a description and an instruction, where I describe what is in the Lakehouse gold. This is just a piece of text, a few sentences about what can be found in this data source. This is very helpful for the model when you start asking a question in English. It wants to understand in what database or Lakehouse or semantic model to look. And using the data source description, it can quickly understand what type of data can be expected in that data set. And then I have data source instructions. There is some general knowledge in here. And there is this big piece of error that I've created in here, because the 9/11 attacks did obviously not happen during the 2009 period. So COVID did happen. Let's take out the 9/11 attacks. That was a decade earlier. I want the model to include general knowledge. It is a GPT-5 model that we know from OpenAI and ChatGPT. So it knows a lot about things that happened in the world in 2019, 2020, and so on. So when I start asking why the taxi trip numbers dropped during that time frame, it should understand that this was COVID. It can then analyze and quickly pinpoint where things happened. I've also put in table descriptions. Why? The table descriptions that I have in my Lakehouse are quite technical. There's underscores, there's gold in there, there's abbreviations. So I have DO and PU for drop off and pick up. So I'm telling the model this is a dimension with drop off locations, with pick up locations, and that's aggregated to zone and borough. When asked about, this is a paragraph that when I ask about relations data, for example, busy times for taxi trips in a borough, make sure to follow the relations between tables. So the model should understand that it can follow foreign key, primary key relationships in the tables. And now I understand that in a Lakehouse there is no formal foreign key, primary key relationships, but fields can be joined together in order to derive an answer. And I will show example queries in order for the model to understand what I mean with that. And then there's other instructions that it needs to be aware that the dataset is very large and slow, and that it should use the semantic model as much as possible. Now, going over to the last piece of thing that we can configure here, that's the example queries. What we can do is we can give it examples of natural language queries. For example, I want to know in 2023 what were the most common pick up to drop off zone pairs with trip count and average distance and the average tip amount that was given. Now the tip amount is not in the semantic model, it is in the data source Gold Lakehouse. And what I've done is I've created the SQL query to answer that question by hand. And for most common, I've said pick the top 25. Pick the pickup borough and zone, drop off borough and zone, and give me the trip count, distance, and tip amount from the taxi data partition by year, join on dates, join on locations, where the year is 2023, group by, and do an order by so that I get to see the most popular one on top. Now, this does a few things. This helps the model understand the more complicated questions that go across many tables. It also helps the model understand how I actually set up my analyses. So without this information, the model might not understand that pickup location ID is the same as the location ID in the pickup table. But by putting in this example query, it knows that these fields can be joined on. So the queries that I put in here can actually be analyzed for the model to create its own queries that are then valid. I've put in another example for 2024, pick the pickup and drop-off zone pairs where riders tip unusually high compared to what you'd expect for that given trip distance, and show the top 10 biggest positive tip surprise pairs with the average tip, expected tip, and trip count. This is an even more complicated SQL query. I've used the common table expression here with pair stats, with the averages, and then I'm looking where that number is unusually large. So these are queries that I've created manually. I know SQL, so I can do that. And it helps the model understand how I think and how the model is actually created. Now let's hit publish, because we successfully published the data agent. And what we're now going to do is we're now going to test the agent response. So I'm going back. No, let's keep this open for now. That's fine. Now I'm asking what was the average trip distance traveled in 2023 for taxi trips originating from Manhattan. This should refer to the semantic model. We can validate that it is actually doing the semantic model by opening the query that it is going to generate here. It should understand that Manhattan is a borough. It does that. Trip distance in miles, blah, blah, blah. All right, steps completed. Looking here. And indeed, we're using a DAX query, which means that we're looking at the semantic model. So the data agent did as it should. This is actually really cool. And the average trip distance was 4.46 miles. Now show the average trip distance. Now I'm asking the model to show the average trip distance originating in Manhattan, the same as last year, as the last question, but where the drop-off location was outside of Manhattan. And drop-off location is not in the semantic model, so it should now be looking at the Gold Lakehouse, and indeed it is now looking at the Gold Lakehouse because it understands that drop-off is not in the semantic model. The average trip distance was about 10.56 miles, notably longer than Manhattan origin average because we are leaving the borough, which makes it a longer trip. And again, we can look at the query that was generated to answer this question. And what we're doing here is we're looking at the average of trip distance from our fact table. We're joining on dates to find the calendar year 2023. We're joining to pickup locations and drop-off locations, and this all looks pretty good where the borough is Manhattan and where the drop-off borough is not Manhattan. So the query that is being generated by the data agent here is perfect. The answer is therefore also very reliable. One more thing I would like to test is whether it can cook. And I'm trying to trick the model into giving me an apple pie recipe. It is actually working. I did not try to do this. I did not prepare for it to do this. But apparently the data agent is giving me this classic apple pie recipe where we have ingredients and instructions and we need to preheat the oven and bake and cool it off for at least 2 hours before serving. And we can then enjoy our classic apple pie. So this is actually, I mean, it is expected. The GPT-5 model definitely knows how to bake an apple pie. But now I'm spending this very expensive fabric capacity on apple pie recipes, and that's something I might not want to do. So let's head back over to the agent instructions. Okay, I've put in an additional response guidelines. I've said only respond to questions about taxi trips, data analysis and such. Do not steer off topic. Tell the user it is too expensive to use fabric data agents for other things than data analysis. Now let's see what happens. Give me a blueberry muffin recipe. And now indeed the model is telling me it is too expensive to use fabric data agents for anything other. If you have questions about taxi trip data, let me know. So this is actually very important. Within the agent instructions and within the data source settings and instructions, you want to include things that you want the model to do, but you also want to include things you want the model not to do. That's very important to put in these guidelines. Now, in the GPT-5 model, there's already a lot of guidelines. You cannot generate things that are crimes or dangerous or harming others, but you can generate things that are very off topic for your data analysis, and you will burn through your compute units, your fabric capacity. In a later video, I will talk about what the actual costs are for a data agent. But for now, let's understand how we can actually optimize our data agents. And as you can see today, we can create a semantic model with measures and with aggregations. Then we put in the underlying lakehouse as well. We put both of them in the data agent, and we tell the data agent to look at the semantic model where possible because it's fast and efficient and cheap, and revert back to the Gold Lakehouse wherever necessary. It's a little bit slower and more expensive, but we can answer way more questions. And we've also looked at how we can then set up the agent instructions and data source instructions in order to fine-tune the model's responses. If you like this video, subscribe to my channel because every week I will be teaching about Microsoft Fabric, and I'll see you next time.